It's a great honor to introduce our Chinese standard Mahjong AI here. Mahjong Sync Team Report. I'm the leader of the team. My introduce is divided into these parts. First, introduce the honor we have won. There are some photos. Since 2011, I have led the team to participate in the China computer game competition for 10 consecutive years and have achieved good results in many projects. In August 2019, I won the 22nd Computer Olympiad AI Fight the Landlord AI Champion. Here are some winning photos. Our Chinese standard Mahjong AI development process is full of challenge. From February 2020 to May 2020, designing and coding Mahjong AI, I was coding Monte Carlo method, simulating Mahjong game process, and designing dividing tiles algorithm, etc. During that period, my AI was topping the Mahjong game ladder of both. From May 2020 to July 2020, I did more winning type of fun. For example, half flash and two dragons, stabilizing and strengthening Mahjong AI by debugging it on the Boson Online. From July 2020 to December 2020, making a local tester, I can run Mahjong AI game on my own machine all day and night. Actual test results show the weakness of AI. I can find a solution to improve Mahjong AI in this way. Thanks my team member Rong Zhang for doing this good thing. Modifying the local tester for new game rule fixed a serious bug. Fun calculation. There are 81 scoring hands or way to end the game in Mahjong. There are as follows. These hands can also be classified by type. The winning rule of Mahjong includes a variety of funds. We must write algorithm for calculating funds for AI. But calculating the fund is very troublesome. Very lucky, Boson team was shared the code of calculating fund algorithm, so contestant can focus on search algorithm. Conservative estimate, we will spend half a year to finish a stable calculating fund algorithm for Chinese standard Mahjong. Boson team's calculating fund code is based on stream processing. I think the algorithm based on integers may be 3 times the efficiency. Self-game judge system. The photo is our local tester. It helps us find some key parameters after testing day and night. For example, we find the best parameter value for self-drawing after 1 million tests. In December, we found a serious bug after preliminary. Local tester was very important to help us find it. After fixing this bug, our AI became much more stronger. Local tester is a very important tool to test and improve AI. Monte Carlo method. Mastering the game of Go with deep neural networks and tree search is DeepMind's paper on AlphaGo. It discusses how to use Monte Carlo tree search and deep neural networks technology. How to learn from the results of this paper is our team's research focus. After a certain period of research, we found that the Monte Carlo tree search technology can achieve the ideal result in theory when the computing power is sufficient under the condition of a complete information game and relatively single victory goal. But Mahjong is an incomplete information game, especially each draw is random. Monte Carlo tree search technology does not seem to apply, so we decided to adopt Monte Carlo method instead of using Monte Carlo tree search. Simplify victory goal. The victory goal of Chinese standard Mahjong is diverse. It's very different from traditional games such as Go, Chinese chess, etc. There are 88 different combinations. It needs 8 points to win. At first glance, it's very tricky. We conclude that this goal can be simplified with certain skill through sufficient summary and induction. We have summarized 16 ways to win. For example, what types? Reason flags for selection. The chance of appearance is very high and has a high score. Another, half flash. It's the basis of some high-power fun types with words. For example, big 4 wins, small 4 wins. 2 dragons. The chance of appearance is very high. It has some points, which is the basis of some high-powered fun types with words. For example, big 3 dragons, small 3 dragons. Rollout generation. In the paper of DeepMind about AlphaGo, fast rollout policy network is a key technology. How to learn from it in Chinese standard Mahjong AI is the core work of our team. Drawing on the rollout to the end in the AlphaGo paper, massive statistical scores are used to obtain the basis for decision making. The effectiveness of this is based on the speed and the quality of the rollout. In fact, our algorithm can simulate more than 10,000 times in total within a 1 second time limit. We have long-term observations and found that each candidate choice only needs about 300 simulations to make the result very convergent. Our team began to register for the competition in April 2020. The competition was originally scheduled to be held in early July 2020. It takes only 2 months to develop and iterate training model. The team decisively decided to use human Mahjong experience hard coding to complete the writing of rollout logic. This hard coding is based on gradually narrowing the distance between the current hand and the victory goal. As shown in figure, 12 of the 14 cards in the current hand have satisfied the lesser honor and needed. Only character 5 and character 7 do not meet the requirement. So the distance target value for this is 2. Quick dividing. I won golden medal of the Fight the Landlord in the 2016 second Computer Olympiad. I have a special understanding of the Fat-to-Landlord card dividing process. The performance of the Fat-to-Landlord AI card dividing algorithm developed by me is very high. The use of machine learning in combination with an efficient card dividing process can reduce computing power by several orders of magnitude compared to only using machine learning. Mahjong AI also requires an efficient dividing process. In our Mahjong AI, due to the efficient process of dividing the cards, the subsequent rapid and efficient generation of rollout becomes possible. In 1 second of actual testing, our card dividing algorithm can complete 1,014 card hand dividing on average. This is a solid foundation for us to perform a sufficient number of rollout and Monte Carlo simulations. Model the opponent. The related algorithm used in the traditional two-person complete information game has an underlying assumption. The opponent also evaluates the situation according to his own situation when new evaluation system. Simply put, I think the opponent will think so too. Humans plan Mahjong with obvious different styles. The 4 AI Mahjong game assume that the other 3 AIs at the same stable also follow their own routing to understand the subsequent evaluation of Mahjong, where the randomness has become huge due to the different order of drawing. After several months of online observation of the behavior of various AIs on the Boson ladder, we prove that this assumption is not true. The styles of different participating AIs are very different. In other words, it turns out that for the 4 AI Mahjong rules, the understanding of I think the other party will think so too is wrong. After a period of research and analysis, we conclude that it is difficult to be effective enough to analyze opponent information for the Mahjong GB rules. The result of our own opponent's information logic analysis has actually led to the reduction of AI's offensiveness and some meaningless defenses. In the final winning consideration, we give up the analysis of the opponent's information and use more computing power for the offense. The latter practice has proved that a good offense is better than a defense, and the quickest victory is the key. Other things to see. I think the time limit for C++ and Python in this competition is open to discussion. C++ is limited to 1 second and Python is limited to 6 seconds. This is unfair to C++ contestants in my opinion. Check the log record results in the evaluation system. Deduct the general input and output. C++ contestants only have 8 million milliseconds for various algorithms to run, but Python contestants still have 5,500 milliseconds for calculation. I think it is fair to increase the C++ time limit to 2 seconds. Of course, there is a slight difference between the ranking of the ladder and the rules of the finals in the weight of victory. At this point, the core issue is the difference between winning faster and the biggest mathematical expectation of winning points. Further refinement is the need to win faster or more, pursue self-joy. We found the balance point parameters through local simulation of millions of games. This photo is our AI's ladder curve. Whether the Mahjong competition system can effectively overcome the influence of luck, I also have certain thoughts. The specific theoretical analysis will not be carried out. Personally, this is a problem in another field, but there is an interesting experience to share with you. Our AI's ranking on the ladder began to take the lead around May 2020 before the game is confirmed to be adjusted to the duplicate format. Afterwards, we modified the source code to adapt to the duplicate format. This modification in middle May caused a serious bug. Then we found that the performance on the ladder was significantly worse. But the results of the duplicate format were better. This makes us relax our vigilance. The AI with a serious bug participated in the preliminary round in middle November and entered the final with the third preliminary. We discovered this bug in December when we modified our local tester to adapt to duplicate format. We modified this bug and then found that the version after modified bug was significantly ahead of the version before the bug was modified in local mass testing. However, the results of the modified version in several simulation games of the duplicate format dropped significantly in December. Perhaps the rule of the Mahjong game itself determines that the element of luck is very important. To fully evaluate the strength of Mahjong AI, a sufficient number of games is required. However, how to obtain the evaluation results stably and convergently with a relatively small number of games in the limited game time is another topic worth of research. This photo is our AI third in the preliminary round to the final. Thanks.